Okay, so I'll jump into it. So to all the attendees, I really appreciate you spending some time with us. I really appreciate you continuing to, for those of you that are returning to all the webinars we've been giving during the lockdown. I appreciate you continuing to come back, and hopefully this will be interesting for you. It's a little bit different than what we've been doing. We've been doing a lot of things around more sort of traditional databases, and although they're cloud native databases, things like Snowflake, things like BigQuery, we thought it'd be good to jump in and do a little bit on the Kafka side, because we do regularly use Kafka on projects, and there's still a big ecosystem for Confluent and Kafka out there, and it has a lot of relevance to projects that we build and deliver today. What I'm going to talk specifically about is really a project that we did, and we chose to use KSQL on, and also chose to use Kafka Streams for some of the integration. And we'll walk through that project a little bit at the beginning, and then we'll talk about some of the components that we built for that project and actually open sourced. And we'll demonstrate some of the build techniques and deployment techniques we used for KSQL and for Kafka Streams on that project. So this is me. My name is Stuart Bryson. I should really update that slide. I'm no longer the owner of Red Pill Analytics. Red Pill was acquired in September. I am still the CEO, but we are a wholly owned subsidiary of a company called Anive now. I gave this slide deck some time ago, so my apologies for not updating this. I actually gave it at the Kafka Summit in New York late last year. So apologies for that, but the social media handles are still relevant. If you choose to follow me, I think that would be great. I'd really appreciate it. A little bit about Red Pill Analytics. I'll move through this pretty quickly. If you're interested in what we do, I think sometimes it's helpful just to show you some of the partners, technology partners that we work with. And when we build analytics for customers, analytics solutions, data products, analytics dashboards, data warehouses, data engineering solutions, these are the collection of tools that we typically use. There are some things that aren't on here that we use from time to time, but in general, this is where these are these solutions and the technologies that we believe in and the ones that we've partnered with. So you can see, moving from the left, you can see the different data warehouse technologies we use. Starburst is a different thing. It is a data warehouse, but it also is a federation layer over other data warehouses. It's a really interesting technology that we started partnering with lately. But that's sort of our data warehouse tier. Our analytics tier, Looker, Power BI, Tableau, Oracle Analytics, of course, we have a deep history there as well. And then data engineering, there's a whole combination of things, and clearly you can see Kafka there, and that's what we're going to talk about today. Something interesting that we launched recently, our strategy consulting business, we've named the Architect Room. It's had that name for a little bit. And this is where we go in and take a look at maybe you're thinking about modernizing, maybe you're thinking about migrating to the cloud, maybe you're thinking about what could go to the cloud, what can't. So a lot of our engagements begin with an architecture engagement, and we call that the Architect Room. But we're offering this Agile edition of the Architect Room, which is a 4-hour strategy engagement that we're going to give to customers for free to hopefully, get the wheels moving, maybe get some customers that are thinking about some things and not quite sure what direction to move, need a little bit of advice, some strategy, consulting. And so this is the service we offer. We focus for the Architect Room, we typically focus on one of the 4 pillars down below. So crew is where we discuss team structure, optimizing your team for, optimum efficiency. We talk about the performance of your data platform, work on ways to try to improve performance. Process, this is the entire process that your analytics go through. And then finally, we try to squeeze value out of everything we do. So try to find ways to sort of lower total cost of ownership, look to remove any undifferentiated heavy lifting you might be due, find cloud services that can match the on-premises services that you're using with lower overhead and lower maintenance. And so if you're interested, please, you can see, reach out to us at RedPill on Twitter or at Stuart Bryson. And I think there are some communication avenues also by which you registered for this webinar. So there's probably an email address somewhere that you could reach out to us. So please do that. Now we'll jump in. So for the agenda, I'm going to do an overview of the project where we used Kafka as sort of the central nervous system of a data integration platform. And some of the challenges, Kafka and KSQL and Kafka Streams are all great products, but there were a few challenges we encountered on this project, and we had to find some ways to automate our deployments. Really, we had to find a good source control development environment experience for our developers writing KSQL. And we had to find a good way to glue all of these, when we're using KSQL and Kafka Streams together, find a good way to automate the entire deployment. So that project is the inspiration for this talk. So we'll talk about the KSQL implementation we did at that project. We'll also talk about Kafka Streams, and I'll show you, obviously there's Gradle over there. Gradle's a build tool. We'll get into kind of what Gradle is in a minute, but we'll show you how we used a Gradle, a software build tool to treat all of our different development tiers the way you would kind of treat a Java project in all frankness, and how we built artifacts, managed deployments, all of that. So that's sort of the overview. I'm not going to talk a whole lot about Kafka Streams in the slides and really in the project. I'm going to focus more on KSQL for that, but I am going to show you how to build a Kafka Streams application using Gradle and how to run it, how to manage the artifact, and how you would deploy it in a production system. So this talk that I'm giving sort of came out of a 3-part blog series that I did on the Confluent blog as a guest author. And so if you're interested in diving in some more about, this is an hour webinar, obviously we can't get into everything. If you're interested in following up on this, you want to know a little bit more about it, there's the 3-part series there on the Confluent blog. Just go to the Confluent blog, search for my name, Stuart Bryson. These 3 articles will show up. And I wanted to just give a quick explanation of something interesting that's happened with KSQL lately. And it's not that it's really a new product, that KSQL DB, which is the new name for KSQL. It's not really a new product. It kind of is though. So they took the core of KSQL and put a whole lot of wrapping around it to make it very, very easy to build SQL-based applications using Kafka. Sort of to make the end-to-end ingestion, capture, ingestion, processing, delivery, all part of one coherent product. Now, unfortunately, I'm still using KSQL, the prior version of KSQL. I'm on 5.4.2 of Confluent for this talk, which was a blazing new release until 5.5 came out. 5.5 came out just recently within the last few weeks, and KSQL DB became a standard component of that stack. Unfortunately, I'm still using KSQL, the old KSQL server, at least old as of a few weeks ago. But what I will say is that I'll talk about a Gradle plugin that we built for automating KSQL deployments. And what I will say is that absolutely works with KSQL DB. There's nothing, the REST interface is still the same. Then we interact with the REST interface. So everything that we do in that plugin is supported in KSQL DB. And actually the plugin tests against KSQL as part of the build process. So if you're thinking about moving to KSQL, you're concerned that, I'm still working on the old KSQL server, don't worry. Everything you're going to see here will translate 100% to KSQL. So the project inspiration. So what we had a customer that had purchased Oracle Warehouse Management Cloud. So that is a product that will manage warehouses, really. So if you've got a warehouse where you ship products from, you need to manage all the items that are coming into your warehouse. You need to manage all the items going out. Keep track of all of those, obviously. Keep track of inventory levels. Also, as employees badge in and badge out of the warehouse, the product can manage that as well. It is a cloud-based solution for running warehouses, really, distribution centers. And so it was previously called Logfire before Oracle acquired it. So our customer was, kind of changing some of the ways that they were shipping products. They had always shipped from a few central warehouses. You can think about these big, huge warehouses where everything ships from. And they were moving more, although those warehouses were going to continue and their core business was still sort of going on the way it always had. They were rolling out a series of just-in-time shipping centers. So smaller drop ship style engagements, that same day, next day approach to shipping. And also they're a big player in industrial vending. So if you're and that is because they sell mostly industrial products. If you are a factory or a manufacturing location and you have common parts that you need every day, this customer will actually put vending machines in those factories or manufacturing centers where you can go with your corporate ID, you just swipe it, you can get a part out of it. So they wanted to keep those vending machines full, and they needed these more strategic shipping locations. And what they discovered very quickly is that the same old legacy software they used to run their big warehouses were not going to work. And they really wanted a cloud solution because, frankly, they didn't know where all of these shipping centers were going to be. And a cloud solution where you could just get to it from anywhere quite easily made a lot of sense. So that was the inspiration for the project we did with this customer. Now, because all of those old legacy systems weren't going anywhere, and this was an ERP system, which I believe was PeopleSoft, if my memory, it was PeopleSoft, but also all of their in-house applications that managed their old warehouses, all their inventory systems and all those things. We had to integrate this new cloud solution with all of their standing applications. So if you wanted to kind of, at a high level what this looked like, is we had a lot of source tables and APIs. And so the tables, most of the systems they had in-house, they were an Oracle shop, running on Oracle database. So there were a lot of different Oracle databases that we needed to pull data out of. And anything that really wasn't an Oracle database, whether it was whatever kind of API it was, a REST API, there was some SOAP, there was some file-based transfers that were occurring. This customer was a big MuleSoft customer. And I don't have time to really get into MuleSoft a lot in this webinar, but MuleSoft is a way to really build APIs and build modern applications using APIs. So what MuleSoft team did was wrap anything that really wasn't a relational table in an API that was easy for us to manage. And they did that on both sides. So you can see both on the source and the target, anything that might have been a little messy to deal with, any kind of input or output that wasn't really standard, that we might have had an issue integrating with Kafka, or something that might have required a lot of work to integrate with Kafka. Kafka has a lot of connectors. So we probably could have used those connectors, but the team decided to put MuleSoft around all of those different disparate APIs and present a unified way that we would get data in and out when they weren't relational tables. So at a high level, that's what we had on our plate during this project. Bear with me. There we go. And if we want to drill in just a little bit on the data inside, this is how we really built the architecture. So the customer was already a big Golden Gate user. So using Golden Gate for big data is a great product, integrates really well with Kafka, delivers source tables to Kafka as topics, and keeps those topics up to date in a pinned only style, the way Kafka likes it. So anything that was a table, that was a relational table, they had a big Golden Gate team already. We just started delivering those tables to Kafka. Now, anything that wasn't, again, we were using MuleSoft. So MuleSoft could push these sources into Kafka topics. So MuleSoft has great Kafka integration. And so it was kind of easy, not easy, it was a good part of the project, honestly. But from an architecture perspective, it wasn't spaghetti, right? It was just a couple of ins, a couple of outs. So MuleSoft would deliver from all of these disparate APIs, deliver that data into Kafka topics. You'll notice I've drawn a division between raw data and curated data. So we were bringing into Kafka all the raw data from these applications. I don't know if you can see my pointer, hopefully, but there's no real transformation or logic going on here. It's just get the data into Kafka. So we had a layer in Kafka that really had all the raw data, and that was very valuable. And then we wrote a integration layer using where we put our transformations, our business logic, where we started having an opinion about how the data should be formatted and joined. And so KSQL provided that interface. So KSQL would build, KSQL, as you'll see, especially in the demo, takes data from topics and delivers it into new topics, creates those new topics in most cases. So KSQL is an integration layer to give us more curated data that looked really the way that the application needed it to look, to then be able to pass to a MuleSoft API. So MuleSoft really could have done some of this transformation as well. The customer was all in on Kafka, and KSQL being the transformation layer for delivering this data into Kafka topics. So I believe, bear with me one second. Yeah, sorry, lost my train of thought. So we also had to, as we brought data in from an integration perspective, brought data in to the warehouse management cloud system, we also had to bring it out. Things were shipped. They needed to find their way into PeopleSoft, right, for closing books, and find their way into legacy inventory systems and whatnot. So from that perspective, we had MuleSoft that encapsulated all of the different APIs that were available inside of the warehouse management cloud system. That would then also bring data into raw topics. We would transform it using KSQL into more curated data. And you'll also notice, and I think I might have jumped, let me go back quickly. Where Kafka Streams, we're back into the streaming in, so sorry for jumping around. Where Kafka Streams came into the picture was there were some API calls in this cloud solution that were kind of nasty. So if you wanted to send it a PO, you didn't send it records, you had to send it sort of this big nested payload. And Kafka Streams, KSQL at the end of the day is a SQL-based solution. It thinks rows and columns. And it's not the best thing for building up these sort of nested payloads. So that's where we use Kafka Streams. Kafka Streams, integrates with KSQL, because at the end of the day, Kafka's underneath. So Kafka Streams is a way for you to build applications that can pick up data from Kafka topics and do things with it. So our Streams applications, we use to package up those payloads, deliver them to MuleSoft, and on into Warehouse Management Cloud. Sorry for jumping back. And then so we did some Kafka Streams here on the way into the legacy, back out to the legacy systems. but not so much. So mostly it was just KSQL building these tables or streams, as you'll see in the demo, so that it could be picked up by, again, Kafka Connect could deliver that data back to Oracle tables where necessary. And then MuleSoft could pick data up from topics that we've curated, deliver that to a series of APIs to then fan out to whatever integration points were needed back in the traditional legacy systems. So hopefully that's clear. And then if you wanted to just a little bit more a little better look at sort of these nested payloads, what would happen is we would take the raw data using KSQL, we would curate it, Kafka Streams would pick it up and build these nested JSON payloads that MuleSoft would pick up and then take on to the cloud. So that was the inspiration. So then when we get to the KSQL part of this, I wanted to walk you through kind of what it looks like to build a data integration piece using KSQL. Now, what you'll notice is that it's not that different from any SQL-based solution, but there are some caveats that come into play when you talk about streaming data as opposed to stateful data. So KSQL is a streaming solution. So when you build SQL processes, you may write a simple SQL statement, but that SQL statement is a never-ending SQL statement. So when you issue it, you create a process that continues to stream those results through Kafka. Hopefully that will make sense as we move on. So first we start with sort of KSQL registration queries. And if you want to think about, by the way, I'm not sure that that's a standard name that Confluent uses, but it's something I use to sort of make sense of these two different styles of queries. So a registration query is kind of like DDL. So KSQL can't really do much until data is in a Kafka topic. So when you have data in a Kafka topic, we need to give it a SQL-like structure. So we can create streams or tables on top of existing Kafka topics that already have data in them. So in this case, there's data already being delivered to Kafka from some sort of a different application. There's some application that's delivering data to Kafka. That might be Golden Gate. In the project use case I talked about earlier, it might be MuleSoft writing data there, or it might be any number of ways that you can write data into a Kafka topic. So KSQL picks up when data is being delivered to a topic. And so the first thing we have to do is give a SQL-like or a table-like or stream-like interface on top of a topic. And the way we do that is sort of like table DDL. So create stream or create table, we define our columns, and then a little bit of Kafka specific things down here. What's the Kafka topic that this is sitting on top of? And what's the value format? In this case, it's very simple to use JSON. So this is an example of creating that registration query. Now we also have persistent queries, and they are exactly what the name implies. When I say create table or create stream as select, then as soon as I issue that statement in KSQL, not only do I get that new table or that new stream, I get a new topic if it doesn't already exist. So KSQL will create that for you. And KSQL will also spin up the application or the streaming process to keep that new table up to date as new rows in this example flow into the clickstream topic. We need the events per min topic to be updated as well. And so KSQL, when you issue that query, you're not just issuing it one time. You are creating a persistent query and a streaming process. So when you look at this, there's the interdependencies between these tables and streams is what we really had to solve on this project. I mean, there's always dependencies when you write a single SQL-based application, but in this case, they're sort of multiplied because as you build a streaming pipeline, it's going to be made up of multiple SQL statements. And those SQL statements are creating multiple streams and tables. And each one is dependent on the one that came before it. That's the problem that we had to solve in our developer experience. So in our terminology, and I think it's a common terminology, a pipeline is a group of SQL statements that work together to define an end-to-end process. So our developers were developing pipelines, a SQL statement at a time. Unfortunately, there's not really a great way in KSQL to define or to structure a development process for really tying these things together. So what we wanted to do was make the developer experience very, very easy, right? So the developer could write SQL and not worry about how that SQL gets executed and what dependencies existed amongst SQL statements. In a lot of ways, the framework we built could be used almost for any SQL-based solution, but primarily aimed at Kafka in this scenario. So here are, and I'm using the clickstream quick start from Confluent for this. No customer data being or tables being exposed in this. But this is what the test case I'm going to use for this demo. This is what it's made up of. So we have these three sort of core topics. So that's data already sitting in Kafka topics. But we want to build these tables and streams here. So as you can see, it can get kind of hairy to try to tie, to manage all of these dependencies. So we needed our developers to have a framework that made this very, very simple. We wanted to be able to manage. So by the way, this is how we structured our Git repo where we put our SQL scripts. So source main pipeline, that's the sort of the base directory where we put our SQL scripts. And then you start building directories. Now, by the way, you can, in this Gradle plugin that we wrote, that can then take this directory structure and actually do something with it. It doesn't really matter the names of this, the names of this. It doesn't matter what you name it. All that really matters in any of it is the alphanumeric naming, right? So as long as when you name things, you're describing the order in which you want them to execute. So we wrote a Gradle plugin that would deploy these SQL scripts, always deploying it in the order, the correct order, and doing things that are necessary within KSQL to make those pipelines deployable. Now, you can create as many SQL scripts as you want with whatever name you want. We chose to create sort of 3 primary SQL scripts for each pipeline, and then we put multiple SQL statements in each of those scripts. But you can do what you want. You can have 1 SQL statement per script. You can have a whole bunch of SQL statements per script. But just remember, the more granular you are, it is sitting in a Git repo. So the more granular you are, the better the development, the feature branch development workflow will work, right? Fewer conflicts, etc. So you do want to break it down some. And also you want to make it such that multiple developers can develop at the same time. For this project, we had about 5 KSQL developers all writing SQL-based pipelines at the same time. And they were working with dependencies on each other's work. So what we built here was a process and a little bit of tooling that made such a development process possible. So we wanted to be able to, in these directories, you can see this is the click stream, and we would call that our pipeline. And that pipeline is made up of multiple SQL scripts. So we wanted to be able to manage dependencies within a pipeline, right? So we wanted to make sure that that create ran before integrate and integrate ran before deliver. And if you map that to actual streams and tables, it makes sure that these individual items run in the correct order. So we wanted to manage dependencies within a pipeline, but we also wanted to manage dependencies across pipelines. So there may be things, and there are actually in our case, things in this pipeline that depend on tables and streams that were created in a prior pipeline. So this directory structure and the tooling we built around it using Gradle enabled us to manage a multi-developer experience working primarily with SQL. And as you'll see later, Gradle also enabled us to build our Kafka Streams applications. We built it using we built it using non-containers. And so therefore I'm not going to demo how to build containers in this webinar, but it is quite easy to build Kafka Streams applications using containers now as well. So we wanted to manage all our KSQL dependencies in one place and allow developers to do what they need to do, which is just develop. They don't need to be able to manage how they're going to test their pipelines, how they're going to execute them as part of the development process. They just wanted to be able to run them, and that's what we built. So these are all the things that we wanted to make sure we supported. Multiple statements per pipeline. I think the jury's out on whether that's necessarily a great, the only idea, but that's what we were working with in this project. I think going more granular in a single statement per script might be a good idea as well, but we wanted to support both. So it didn't matter how many SQL statements you might put in a single script. We wanted to be the developer to not really, it wouldn't matter. The developer could just develop however he or she wanted to. Statements, of course, are in script files, and that's sitting in Git. So a .SQL file sitting in Git, and developers need to be able to make changes to those SQL scripts and basically restart their pipelines as part of the development experience. And as you'll see in the demo, that wasn't, KSQL is getting better and better, but it wasn't the easiest thing to do initially in KSQL, and it's still not super easy for you to sort of restart a pipeline, for you to pull down all those persistent queries and restart them because you've made a change to one of the persistent queries in the middle. So what's Gradle? So Gradle, I would love to do a full webinar on Gradle. Unfortunately, I can't, but basically Gradle is an open source build tool. So it's a Maven replacement in a lot of cases, although it also works quite closely with the Maven ecosystem. It's the build tool underneath Android Studio. So if you've ever written an Android app and you're running a build to build your Android application, whether you know it or not, underneath all that is Gradle, managing that. And it's really evolved to build Java projects, Java software mostly. And now it can build really anything in the JVM. It can also build a whole lot of things that aren't in the JVM, JavaScript, Python, etc. So you can use it to build software. And as you'll see, you can actually use it to build things that are kind of software-like or software adjacent, like KSQL processes, right? So we didn't want to reinvent the wheel and write something from the ground up. Gradle has a lot of functionality. So when you look at all the things it kind of already has pre-built capabilities for, things like source control, things like executing things, whether those would be Java executables or pure executables, it's got great functionality for files. And that's the thing that really lured us to this to begin with. We were going to have to do a lot with SQL scripts and making them deployable. And Gradle made that really easy. And also it's got a really strong plugin architecture. So we actually built and open sourced the plugin that you can use now called Gradle Confluent, which we'll get into. So if you like what you're seeing from this KSQL demo, the plugin's available to you. And then it also does things like publishing, ordering of processes, dependencies, and as you'll see in the Kafka, when I show you the KSQL functions piece of this, when we write our custom function, it can also show us how to enable testing. So these are the plugins that we used in the project. Actually, we didn't use Jib, but I wanted to just call that out. You won't see that anywhere else except here, but Jib is the replacement for the application plugin in case you want to build containers for your for your Kafka Streams applications instead of building applications, which you'll see us build here. I was running against the clock to try to get Jib working for this demo, but unfortunately I didn't. I'd never used it before. I thought I'd give it a try. Had to fall back to application, but maybe I'll blog about it sometime. So these are the Gradle Confluent plugin is the one we wrote. So that's the one that Red Pill Analytics wrote. You know, more specifically, I wrote, and we have open sourced and made available to the community. We know of some Confluent shops that are now using it, which is very kind of humbling, which is great. That's exactly what open source software is for. So that's where you can go if you want to go to the Gradle plugin portal. I'm actually gonna, you can just search for that actually, plugins.gradle.com. And you can see all the different plugins, and our plugin is published there, free to use. So if you want to get involved with this project, and I think that's what this screen's really about. If you want to get involved with this project, by all means, we would love a pull request. And there it is. So github.com, Red Pill Analytics, and then Gradle Confluent. So it's open source, pull requests are welcome. That would be awesome. If you have any interest, please reach out to me. So let's jump into a demo. So I decided to do my demo using a Jupyter notebook. And the only reason I'm using a Jupyter notebook, I'm not really doing data science or anything that you normally do in a Jupyter notebook, but it does make rerunning a demo very, very easy. So mainly I'm not recommending everyone goes out and uses Jupyter notebooks necessarily for KSQL. But what I am saying is it's really good to make a demo repeatable and hopefully easy to follow. But the jury's out, so we'll see. So I just want to make sure either from Lauren or Mike that you're seeing that I switched screens to this Jupyter notebook.
Yes, we are.
Fantastic, thanks, man. All right, so first off, if you're interested in the repo, this is not for the Gradle Confluent repo. This is just some samples that I'm running here. So basically, this demo is in this GitHub repo. So if you're interested, that's public, pull it down. You should be able to repeat the steps. And also this notebook is in there as well. So the first thing I want to do is start, I'm going to run the entire Kafka, Confluent, and KSQL environment using containers. And when you have a hammer, everything looks like a nail. So there's great Gradle plugins for managing Docker Compose. So since Gradle is a big piece of this demo, I thought, hey, why not? So you can see, because I've applied a Gradle plugin for managing Compose, I get these Gradle tasks. One of them is Compose Up. And so I'm managing, bringing up my Confluent environment. And you can see it's made up of several different containers. If you know a lot about Kafka, you know there's several pieces that are required to get up and running. It's one of the things that KSQL DB simplifies, if you remember me talking about it earlier. But for this, we're still running the main core components. So you can see we have Zookeeper, a Kafka broker, schema registry. We also have the KSQL server and the KSQL CLI. All those are running on different containers. So the entire stack is being managed by Compose and specifically Gradle. So I'm going to just run a KSQL CLI command, hopefully. Yes. Hold on, bear with me. Come on. Ah, there it was going. All right, we'll do it again. All right, so Kafka's, so my environment kind of spun up, and I'm also notice I'm using this data gen container to generate some data. So we don't quite have all the topics yet. Let's see if we've got it now. So there are 3 topics. So these 3 topics I generated as part of the Compose process that brings up the containers. So you can think of this when you start like a KSQL application, you would have data being delivered to topics somehow outside of KSQL's control. And so that's what you can think of for our use case, we have these 3 topics, Kafka topics that have data being delivered to them. And that's the raw data that we want to transform. So now, what would life be like without any sort of tooling, the Gradle plugin that we built? Well, generally, a user would create a registration query first. And so they would run this. I'm running this using the KSQL CLI. I'm just using a little magic here to make that happen in the notebook. But ordinarily, this would be in the KSQL CLI, and you would issue, create stream. So notice stream is created. So what I've done is I've created a stream, which is really just a data definition on top of that. So this is a registration stream. It's sitting on top of that Kafka topic that already has data in it. So now I want to build a persistent query. So notice this is pulling data from that clickstream topic. This is called events per minute. And we're creating a window with a tumbling window with breaking the data up into windows of every 60 seconds. So when it comes time for me to execute this, notice you'll see the output's a little bit different. We see that events per min created and running. So we now have a persistent query running. Anytime new data gets delivered to that clickstream topic, it will automatically be transformed in a streaming process. As soon as it touches that topic, it'll pull out and be transformed and loaded into the new topic or the new table. So now we can list our topics. It's a command in KSQL, and you can see we have this new events per minute topic. And that topic is up to date with new data, and as data comes in, it will stream immediately into that topic. Now, the immediate problem with really any SQL-based solution, but KSQL specifically, is that when it comes time to iterate on our code, right? We want to make changes to an individual step in a SQL-based pipeline. It's really not as easy as it should be, right? So that you think, well, all I need to do is drop this clickstream stream so that I can make some changes to it. But notice I can't drop it because I have this persistent query running. And so so what needs to happen is I need to terminate that query, and then I'm able to drop it, right? So seems like not such a big deal, but imagine working with a pipeline that has 10, 15, maybe even 20 SQL steps to build an entire pipeline. And so immediately we recognize that developer efficiency using SQL was going way down because of the need to constantly drop persistent queries, terminate persistent queries, and drop tables and streams so that we could then recreate them. So that plus just having a great, structure by which to put our SQL scripts into a Git repo, we wanted some tooling that made that just dead simple for developers. So enter the Gradle Confluent plugin. So there's the GitHub repo for it. If you're interested, again, this is where you can go. If you want to open pull requests, if you want to, contribute, that would be absolutely awesome, frankly. So that's where that is. And then it gets published to the Gradle plugin portal. So you can see we actually released a new version earlier this month. And this is where you can go you just add this snippet to your build script. You'll see some of that in a bit. And your Gradle build process will start using this plugin. Couldn't be easier. So in your Gradle build script, so every Gradle build process has what's called a build.gradle file. And in there, you can put all kinds of great logic. It's DSL-based, domain-specific language. So it's written in Groovy or Kotlin, whatever is your preference. I'm using Groovy. There's a plugins box up here. So to get all of the functionality in a Gradle that the Gradle Confluent plugin gives you, all you have to do is add this in the top, in the plugins closure. And I clicked enable pipelines equals true. Actually, that's the default. The only reason I'm showing you that is that there is, the plugin adds this Confluent closure. So anything that you want to configure about this plugin is configured here. I'm not going to go into all of the different, configuration options. I will say that the API documents are very, very good, and they'll show you all those options. So the first thing we can do is, once I've applied this plugin to my script, I can then go and see what new tasks were added. And I'm going to filter all the different tasks in my Gradle build script by a group called Confluent, which the plugin adds. So now I can see all of the Confluent tasks that this plugin adds. And we're going to get into these, most of them a little bit at a time. So we have these tasks available to us. Pipeline execute is the task that developers use to automate their KSQL deployments. So when they go to, so we'll take a look at the help. The Gradle's great because it's sort of auto-documenting. If you write a plugin, then you're going to see all the tasks and options. And as long as you do a pretty good job in your code of filling it out, you have this help option that shows you sort of all the different options available to the developer. From if they need to make password and username connections to KSQL, they can do that. The from beginning, that's a parameter. If you want to completely restart your pipeline, meaning that you want to pull all data, not just new data, you can set that. You can say, hey, I actually don't create it. I just want to drop it. Hey, I just want to create it. I don't want to drop it. And then there's a lot of other options. You can specify the specific REST URL, and you can also pinpoint a particular directory in the Git repo that you want to run SQL scripts in. If you don't specify that, then Gradle Confluent is going to run everything in your entire repo, at least in the pipeline directory in that repo. So this is a way for a developer to pare down what they're working on and restart or rerun a single pipeline at a time. So I'll demonstrate that now. So I want to run pipeline execute, and the directory I want to run is just the clickstream directory. So let's run that. So you can see we had one object that was already there. We had no queries terminated, one object dropped, and 6 new objects created. So imagine the developer's written a few things. They've tested this run. They've gone back, modified their SQL. They now want to rerun the entire pipeline, not just this one directory, but the entire thing. I'm also going to turn up the logging just a little bit so you can see what's actually going on. And what you'll see is that we're running through that entire directory structure, dropping all the queries that need to be dropped for me to restart this pipeline, terminating any queries that need to be terminated so that we can rerun it. So you notice that we had 4 queries terminated now, 6 objects dropped, 13 objects created. And the interesting thing is the developer continued to do this over and over again, right? Because the plugin just manages it. So no more hunting around for queries to terminate, objects to drop. It just manages the entire workflow for you. So you might think, oh, that's great. I'll actually use pipeline execute as my deployment framework. This is how I'm going to deploy things to my KSQL cluster. Well, you could, and that's fine. Checking out a Git repo to deploy. There's really more and more of that happening these days, so it's not a bad idea. But if you work in a environment where your DevOps or CI/CD engineers expect artifacts, those are artifacts of code, built code, compiled code, whatever word you want to use, published to a Maven repository and an artifact repository of some kind. Well, we can do that as well. So we just needed to add, you notice we're keeping our plugin, but we're also going to add this Maven publish plugin We're going to just use a local Maven repo so that I didn't have a lot of heavy lifting to do. So it's just a file system locally on my machine. And I had to give it a group and a version here. So this is going to be used for building the artifact. And now when I do a build and a publish, you'll notice that I create and publish this archive file. Again, I'm just publishing it locally, but if you had a artifact repository server, then you can actually publish it there. And we can take a peek. I'm doing a zip info. You can see that there's all of our directory structure of our SQL scripts is there in that artifact. But we also build this KSQL script, KSQL script.sql. And that's can be used in case you need a KSQL script to start your cluster. So one of the ways you can deploy to KSQL is to pop a SQL script. It's got to be one. You got to have all of your SQL in one script. Pop that in a particular location and restart the KSQL server. Well, we build that script for you. So you can see I'm just catting it. All of our SQL from all the disparate SQL scripts are placed in that file in order. If I want to deploy, it will use the KSQL REST API. And in this case, it will actually pull our artifact from whatever repository it's published in. In this case, it's just local for me. It will grab it, extract it, and deploy it. Let's run that again with the logging turned up. And you can see that we have a lot of the dependent tasks doing the work. It's extracting the file. And then the deployment process, again, is deploying, terminating queries, restarting them, restarting the entire pipeline. Now, one of the things we noticed quite quickly was that we needed to be able to control some of the behavior of the DDL we'll say DDL, the SQL that gets generated in different scenarios. And we didn't really want developers to have to manage figuring out whether or not they wanted to add things like, for instance, delete topic. Okay, so we didn't want them to have to manually or custom modify SQL in some way to add something like a delete topic at the end of a drop statement. So we added directives. So directives really are just smart comments that control the behavior of the KSQL that we generate. So we generate the drop and the terminate statements. So if there's any modification or enhancement we want to make to those drop statements, for instance, delete topic, we can do that. So in this case, you'll see that I'm running the clickstream. You can see that that directive caused this behavior. So in case you needed to have the top, by default, KSQL doesn't delete a topic when you restart a pipeline. So when you restart a pipeline, it keeps the topic and just restarts, starts refreshing the streaming process. If you actually want that topic to be deleted and recreated, this is one way you can do it, is with our directives. So I'm actually running out of time. I'm going to skip the KSQL user-defined functions. If that's what you were here for, I really apologize, but I'm long-winded. Many of you may know. And basically, this is a way where you can write custom functions inside of KSQL. I'm an old-time Oracle user, so I wrote a decode function just for fun. I walk through how you can build that and deploy it. But I think I'm going to move on, unfortunately, so my apologies. I want to jump to Kafka Streams. So we wanted to build Kafka Streams, really microservices. So every single time that we wrote, you can almost think of when we define a pipeline in KSQL, for us, a pipeline was a microservice, and we didn't want a big Java server running all these pipelines. We wanted individual microservices so that we can replace and deploy a single microservice without having to touch anything else. So I use the word count lambda example from the Confluent docs to show you how we can build this using Gradle. So there's our code, and our code is sitting in that Git repo. Added a few things to my Gradle plugin. I added the application plugin. I also defined a place to publish our zip files. You'll see that in a minute. And also some of the dependencies that Kafka requires for me to build streams applications. So first thing is that the application plugin actually gives us a run command. So instead of just building a Java app, it will actually make it easy for us to run one. So this is the Java application starting. Maybe it's starting clean. It didn't start clean. I got something wrong with this Docker Compose such that I often have to run it a second time. You got me. I have no idea. But we'll restart it. I think it has something to do with my my broadcast address. But anyway, so you can see that this application, this KSQL, sorry, this Gradle run option will start the KStreams application, and you can see it brought it up and it's running. Now, again, checking out a Git repo and doing Gradle run is probably not how you want to deploy to prod. So again, we can publish. The application plugin allows us to build an artifact. And this artifact, let me stop this one. So this artifact actually builds all the start and stop scripts for the application to run just in a local Java VM. So all the start scripts were built and distributed in a zip file, and we published it. So sort of the way I'm walking through with a command line, how you might deploy, delete your deploy directory and then make it again, go get this artifact and unzip it, unzip the application, and then start the application. So this is how what your CI/CD server might do on the location where you want to run this. So you can see we extracted the zip file and started the application all from that zip file. So I have about 1 minute left. I'll just go ahead and stop it. I wanted to show one more thing. So one more thing, of course. So if you have to leave at 2, go for it. But if you want to stick around, I'd love for you to. So we've also written a plugin called Gradle Analytics. So what we do is we capture behavior inside of Gradle and we make it available to downstream sinks, right? So anywhere that you want to publish data. So you can publish it to GCP and get it into BigQuery, publish it to Amazon through Kinesis, JDBC connector in case you want to load it in a JDBC database. But we've also built Kafka functionality inside of our analytics plugin. So if you're interested in that one, there's the Git repo for it. That's also publicly available. But what I want to show you is that at the end of a Gradle run, you can just run the analytics, the producer. So that's going to produce the data to whatever downstream sinks that you have configured. In our case, we've configured our local Kafka cluster that I have running inside of Docker. So as soon as I run that producer command, I now see that I get a few more topics. So I get these Gradle topics. So we got a topic for builds. So there's a topic for tasks, and those are standard Gradle entities. So every time there's a build, we put a record there. Inside, a build is made up of a bunch of tasks. We put a record in there. But we also put our own custom topic for all of the KSQL statements that have been executed. So for instance, this is what I'm just going to consume using the Kafka command, consume the topic that's being written to by the Gradle build topic. So you can see that data is actually in there in that topic. And then here's our custom one. Actually, I got to stop that one. Sorry. Don't know why this one formats so nicely with color and this one doesn't. I believe it's because of the data. It isn't as clean. But anyway, you can see for every KSQL statement, we record that data. So when it was restarted, what the status, was it successful? What was the actual statement? And we're publishing that to a Kafka topic. So with that, I know I'm a little bit over, about 1 minute over, but if there's any questions? Mike, I don't know if there's been any Q&A, if there's any questions.
Yeah, we've had a couple of questions come in. For those of you that haven't asked a question yet, feel free to do so using the chat option at the bottom of the Zoom window here. And while we've got a couple of minutes here, the first question or statement really is in regards to, this is from Bethany. So apologize for joining late and apologize if this is already addressed. But some folks in our organization are leaning towards ActiveMQ. What messaging would you give to use Kafka instead, or Kafka over ActiveMQ?
Yeah, so that's ActiveMQ is an old queuing server. So that they were all the rage once upon a time. You tried to put all your message it's sort of a pub sub model. You have one server that you can publish messages to. And so you have that one server that you would go to and grab messages. What I would say is if MQ or any of those MQ servers, RabbitMQ or any of those that use the Java queuing specification for their architecture, if that works for you, that's great. But what I'll draw the distinction between Kafka, and that distinction is that Kafka is designed to store the data for as long as you want it. You can store it for a short time, which would make it in some ways similar to those queuing servers, minus the Streams API, KSQL, and all the capabilities that you have by adopting Kafka, and all the Kafka connectors that you have by adopting Kafka. So if you sort of forget about all that for a minute, then sort of at their heart, their short-term storage for messages, then maybe those older solutions would work. But the one thing, the main thing that sets Kafka apart is the fact that Kafka is designed for long-term storage if you want to. This particular project that we use Kafka for, they're going to keep messages in there forever, right? It is their long-term storage. And what that does is Kafka makes it able for you to replay the subscription of messages. If you have a new consumer come online that hasn't been around, your Kafka cluster has been around for 3 years and it's got lots of messages in there. You've got a new consumer come online today, and actually it would benefit from having all of the messages that Kafka has. Then you could simply replay that with the from beginning option. So Kafka's main goal really is to decouple production of messages or streams from the consumption of them. And so you can have multiple consumers and Kafka manages that for you. So really I would go in the direction of Kafka, specifically because we have Confluent Cloud now, which can make that application much, much easier to manage and much easier to deploy. And I think you'll get a lot better performance as well.
All right, another question here from Mo. Is Amazon's Kinesis really worth the extra cost for AWS to manage versus managing Kafka ourselves?
So I think what it all boils down to is performance. You're going to get much better performance from Kafka. If your messaging, if the SLA on your message delivery, we're migrating a lot of customers to more streaming technologies from traditional batch technologies, and they're used to getting their data only once a day or updated once a day. And they're like, hey, if the queuing gets backed up for an hour or for 30 minutes or whatever, then we can live with that. Maybe maybe something like Kinesis or Google PubSub is for you because it is very little to manage. If, on the other hand, you have SLAs regarding, exactly once delivery and uptimes and the performance of the delivery of messages, then I would probably go more in the direction of Kafka. And then, with Confluent Cloud, follow their Metamorphosis project where they're making it much easier to run Kafka in the cloud. I think the barriers for Kafka, it is a little harder to manage than some of those serverless options, but Confluent's really plowing ahead on removing those barriers. And I think it's probably, with Confluent Cloud, it's probably worth it to go ahead and go Kafka in the end.
All right, then we'll do one final question here. This is from Larry. Can you please go over the Gradle Confluent plugin again and talk about the functionality it provides?
Repeat that, Jelen. Say it one more time.
Can you please go over the Gradle Confluent plugin?
Oh yeah, so it does a few things. So it provides some functionality for multiple pieces of the Confluent stack. So it provides some hooks for if you're writing Streams applications to make some of that easier. It provides functionality for helping you write KSQL custom functions, or user-defined functions as they're called. But primarily its functionality is for helping manage KSQL deployments. So makes it easy for developers to just focus on writing SQL as part of a pipeline, a data pipeline, and then making it easy for them to iterate on that SQL so that they can start and restart their application to test the output. But also has functionality for making it easy to deploy that KSQL-based data pipeline or pipelines, to deploy those to production KSQL servers, to publish it to artifact repositories, to make it just really easy to take the development and productionize it.
Okay, well, thank you. Those are the list of questions. Appreciate everybody sending those in. Thank you for everybody for attending today. Thank you, Stuart, for leading us through this excellent topic here. Within the next day or so, we will send out the recording. If you have other questions, feel free to hit us up on our website or on social media, and have yourself a great day.
Thank you. Thanks, everyone, for attending.
Thank you. Bye-bye.